Hey folks, the question has always been, can you have your cake and eat it too? Well, today I want to show you how you might be able to do that with Python and Rust. Python is super easy to work with. Rust is type safe and performant. With the latest tools we have, we can combine those both together into a pretty cool AI agent application. I've got a couple windows open. Let's acquaint ourselves with what we've got here. On the left, we've got the Google Cloud Shell, where I'm going to be able to execute some commands. On the right, my blog post to help walk through this article. So first, what we're going to need is to create the project. So we will run these commands here, which will launch a tool called Maturin, which is going to configure our project, get us all set up. And so let's run that here. And I am creating a new project, fast diff MCP. So the purpose of this project is an MCP server, a model context protocol server. And I'm just doing one thing, something pretty easy, diffing strings. And so I want to use the Rust similar library to do this diffing, and it's much faster than the built-in Python library. So let's go ahead now and take a look at this project. What I'm going to do is change into that directory, open up the editor. Let's take a quick look at what Maturin here has created. So we've got our PyProject toml that describes the project. We've got a cargo descriptor as well. This is Rust package descriptor that explains our project. And we've got a very basic hello world type of Rust library. And so what we're going to demonstrate is this Python to Rust interoperability from the starting point. Okay, so the very first thing that I'm going to do is go into the auto-generated PyProject toml, and I am going to update the minimum version of Python because fast MCP, the MCP server we use, requires 3.10 or above currently. All right, now let's just do the needful when it comes to Python environments. So I am going to now drop down into the terminal here from my Cloud Shell editor, and I will create a virtual environment. This is just what's going to hold the different Python dependencies so that I'm working in an isolated environment. So let's go ahead and do that. I will create the environment, and then I can now source it and have it be active for me. All right. So now let's take a look at the next step, what we need to do here, which is add some of our project dependencies. So we can first add fast MCP to our project. So here, what you're going to see soon is that it's going to be added to our requirements after it installs here. It will take a little while. Meanwhile, there are some development tools that we want to include. So these are optional. These are not required at runtime when you're hosting your application, but they are required during the build process. Let's walk through what each of these are. So we've got the stubgen library, which is going to help us generate Python stubs that help you with autocomplete. For later in the article, we do some benchmarking to compare Python and Rust diff tools. That's why there is this faker tool that's basically going to generate some synthetic strings for us to match. PyPerf, again, for benchmarking, and Maturin as well. We're also going to add the project dependencies. So we have now got this working. You can see that the dependency of fast MCP has been added to the server, or rather the project dependencies. And now let's go ahead and add these other dependencies. So what you're seeing here is we're going to do two sets of adding dependencies. First, we're going to add dependencies from the Python ecosystem and then to the Rust ecosystem. So let's take a moment here to add all those. Let's move on to checking out Rust. So Cargo is fantastic. I've been using this. Basically, it's required if you're using anything in Rust. Very fast for installing dependencies. Let's go ahead and add the diff library similar, as well as our PyO3 library for creating the bindings between Rust and Python. Okay, so we've installed that. Now let's just go ahead and make sure everything is installed properly. We're going to run uv pip install. So if you're wondering what UV is, it is a very fast package manager, provides the pip functionality. It's built into Google Cloud Shell, so you don't need to install. Okay, so while it's doing all this great work here with the dependencies, let's go ahead and get into the Rust logic. So I'm going to copy and paste this code here, and let's replace our existing library and take a look at what's going on. Okay, so we have one function here, our unified diff, and it's pretty straightforward. It's using this text diff library. We have a string that's the original and the new string. We call that, and then we output the result here and return it in the function. We also here have our module that we're going to export, and we add this function that we just defined here, unified diff, to that so that it's made accessible to Python. And then finally, just for good hygiene, we created a simple test to make sure everything's working fine. And this is going to run a diff and make sure that the results are correct. That's it. All right, so let's now try to build the module and see if it works. So first, let's run develop here. We're going to build and compile everything. Coffee time. All right, and we're almost there. PyO3 might take a little bit. And cool, we're good to go. And now let's run our tests. So if everything is working fine, this should just work. The moment of truth. Almost there. And wanted to provide a little bit of extra information if we run into an error. So cool, we hit it on our system. On Mac, my personal laptop. So what we need to do is update some environment variables to point to the Python version so that the linker knows exactly where to find everything. So in this command, what I'm doing is I'm getting some configuration of my Python environment, setting as flags, and then running cargo tests. So there are other ways to handle this, but this is just a quick way that explains what's going on. So we've hit that error, and we can now set the flags and run cargo test. And fingers crossed, everything works great. Compiling, building. All right, it works. Awesome. Okay, so now let's create the Python stub. So you don't have to do this, but this is nice because if you're in your Python code, you want to be able to get autocomplete, and that's how we can do that here. So I'm going to run stubgen on our project, and what it should do is create stub files for us. Let's go ahead and we'll see that in a bit. So now let's move forward. Let's see what we need to do from a Python perspective. So let's copy in this Python code here. Got a little bit to copy. And let's create a file called server.py for running our model context protocol server. Let's walk through what we've got here. We have two tools we've defined with annotations here. We've got our Rust package, or rather our tool function here, and we've got the built-in Python as for a comparison. So you don't really need this, but this is helpful for the benchmarking that's part of the article. And so let's also just note that we have a little bit of logging, and then we run the server. So let's now take a little bit closer look at this tool and how we connect to it. So this was the name of our Rust package. Again, we imported unified diff from there. So notice it just works. Here we're leveraging that, and you can see that the binding is there. So we've got the nice string explaining it. So here the Python binding was created there as well. So we're good to go. Don't see any Pylance errors or anything like that. Seems to be working great. But we'll see when we actually run the server. So we're now ready to run everything and install the server. Let's give it a go. So I am going to now install all the dependencies now that we have our Rust code, our Python code in a package. And then we're going to run the server. And you'll notice I've changed the window on the right side where I have a few commands. It'll show you with curl how we can connect to the MCP server and make sure everything's working great. So let's now run our server, uv-run server.py. Again, note that it will be running this code here. And it'll take a moment to get started. You'll see fast MCP load. And we see we are running on port 8080. We're good to go. What I'm going to do next is create a new window here where I can run these curl commands. And so let's give each of these a go, and I will explain what they're doing here. So here's what you see is the first one. So we're going to do 3 different commands. So you could be using a web interface for this, of course. Your agent's going to use it, but let's see what's going on under the hood here. So we will first initialize a session. So using the latest streamable HTTP protocol, we are going to say, hey, we want to start a session, and we're going to get that session ID back. And so we've done that, and now we have a session ID variable that we're going to use for the next step of the process. So with the model context protocol, as you might imagine, there's a bit of back and forth of acknowledgement prior to making the call. So the next thing that we are going to do is notify the server that, yes, we have received the session ID. So here we go. We've got that acknowledgement. And finally, the fun part, let's go ahead and call the tool. So I am going to now run this final curl command. And you can see we've made the modification. Hope this is a great introduction to Python and Rust interoperability. Hope you all have a great day. Thanks.